Hey everyone, welcome back. Today we're looking at a talk by Andrej Karpathy, one of the co-founders of OpenAI, the former head of AI at Tesla, and the person who coined the phrase vibe coding. In this conversation from a recent event, he shares how his own relationship with programming has changed and what that shift means for everyone building with AI today. He opened with something surprising. He said he's never felt more behind as a programmer, and this is coming from someone who helped build modern AI. What happened? Around December 2024, he noticed that AI coding tools had crossed a threshold. The model stopped making mistakes he had to fix. He could keep asking for more, and it just worked. He stopped correcting the output, started trusting the system, and realized he was vibe coding. He says many other people had that same moment around the same time. Let's start with the big picture shift Karpathy describes. He frames what's happening in software as a transition across 3 different eras. Each one requires a fundamentally different way of thinking about programming, and we're right in the middle of the third one right now. Here's how he breaks it down. Software 1.0 is traditional code. You write explicit instructions, and the computer follows them exactly. Software 2.0 is machine learning. Instead of writing rules, you create datasets and train neural networks to learn the patterns. Software 3.0 is what we have now. You write prompts, and a large language model interprets them and figures out what to do. Your prompt is your program. The context window is your lever. Programming has become prompting. He gave a concrete example of what Software 3.0 actually looks like in practice. When you install OpenClaw, you're not running a shell script. You're copying a block of text and pasting it into your agent. The agent reads it, understands your computer environment, handles the setup intelligently, and debugs problems in a loop, all on its own. You don't specify every step. You hand the task to an intelligent system that figures out the steps itself. That's a fundamentally different programming model. His most striking example was his own app called Menu General. He built it to take photos of restaurant menus and generate images of each dish so you could see what you were ordering. It had a full backend, API integrations, and Vercel hosting. Then he saw someone accomplish the same thing with a single prompt to Gemini. The model returned the menu photo with dish images overlaid directly onto it. His entire app was unnecessary. He had built it in the old paradigm. In Software 3.0, the app itself often shouldn't exist. Now let's look at one of the most important concepts in his talk, verifiability. This idea explains a lot about where AI is extraordinarily powerful and where it still fails in embarrassing ways. Karpathy says AI models are what he calls jagged. They're extraordinarily capable at some things and surprisingly bad at others. The reason comes down to training. Frontier labs use reinforcement learning, where models get rewarded for correct answers. That works best when there's a clear right or wrong, like in math, code, or chess. So models become very strong in verifiable domains, and noticeably weaker in areas where correctness is hard to measure. The jaggedness reflects what made it into the training data and the reward system, not any hard limit on what AI can eventually do. He gave a funny but revealing example of the jaggedness problem. He asked a state-of-the-art model whether he should drive or walk to a car wash 50 meters away. The model said to walk because it's so close. And yet that same model can refactor a 100,000-line codebase. The car wash question requires everyday common-sense reasoning that wasn't specifically trained on. The model is inside the circuit for code and outside the circuit for obvious real-world logic. That's why staying in the loop and not fully trusting the model is still important. For founders thinking about where to build, Karpathy's advice is to look for problems that are both verifiable and underserved by the major labs. Verifiability matters because it means you can apply reinforcement learning fine-tuning yourself. You don't need a Frontier Labs resources to do it. If you can define clear right and wrong answers in a valuable domain, you can build a specialized model that outperforms general models on your specific task. The opportunity is in valuable verifiable domains that the labs haven't prioritized yet. Now let's get to the distinction at the heart of his talk, vibe coding versus agentic engineering. These are 2 different things, and he thinks both matter, but they serve very different purposes. Vibe coding is about raising the floor for everyone. It means that anyone can now build software that works, even without deep programming knowledge. You describe what you want, and the AI builds it. It's democratizing and genuinely exciting. Karpathy embraces this and spends a lot of time on side projects just exploring what's become possible. His side projects folder, he says, is extremely full. The floor of what non-programmers can build has permanently risen. Agentic engineering is something different and more demanding. It's about preserving the quality bar that professional software requires. When you're building production systems that users actually depend on, you can't introduce security vulnerabilities or brittle abstractions just because the AI generated them. Agentic engineering is the discipline of coordinating AI agents to build faster without sacrificing your standards. He thinks the skill ceiling here is far above what used to be called the 10x engineer. When asked what separates a mediocre AI user from a truly AI-native engineer, he pointed to how much they invest in their setup and how thoroughly they use available tools, the same way strong engineers use to master their editors and environments. He also said hiring needs to change. Instead of coding puzzles, give a candidate a large project, build a Twitter clone, secure it, and then use 10 automated attack agents to try to break it. If it holds up, you've found someone who can engineer with agents. He closed with a quote from a tweet that stuck with him. You can outsource your thinking, but you can't outsource your understanding. As agents do more of the actual work, the bottleneck becomes the human, who needs to understand what to build, why it matters, and how to direct the system. If you don't have that understanding, you can't give good direction, and the agents will build the wrong thing very efficiently. So what should you still learn deeply when intelligence is getting cheap? Karpathy's answer is taste, judgment, and fundamentals. Agents write bloated code. They copy-paste, create awkward abstractions, and build things that work but aren't well designed. You still need to understand the underlying principles, not to remember every API call, but to recognize when something is wrong and to set the right direction. The human is still the architect, even when agents are doing all the construction. Karpathy's message is both exciting and sobering. AI is not just faster software. It's a new computing paradigm. The people who will thrive are those who understand when to trust the agent, when to step in, and what genuinely good output looks like. That requires real understanding, not just access to tools. That's it for today. See you in the next one.